Hello, my name is Francis and this is my oral midterm. I was doing homework 5, question 2. Assume the integral, the double integral with respect to x and with respect to y exists, and we are supposed to find the equivalent double integral with the order of integration changed. So the first thing that I usually do, I usually check the order of integration, which is dx dy, which is going to tell me that this function is first of all integrated with respect to x and then integrated with respect to y. So this inner function here represents the x limits, or the limits of integration for x. So the lower limit is minus 9 minus y squared. The upper limit is the square root of 9 minus y squared. And then the lower limit for y is 0, and the upper limit for y is 3. So just by looking at it, we can take these limits for x and put them in this form. So x is less than or equals to the upper limit, which is the square root of 9 minus y squared, which is greater than or equals to negative the square root of 9 minus y squared. And then we can take either of these and equate it to x, and we are going to get x squared equals to 9 minus y squared, which is going to give us x squared plus y squared equals to 9. Now x squared plus y squared equals to 9 is a circle that goes through the origin with radius 3. So the radius value is going to give us the limits of integration for the x's. You can trace out, first of all, before drawing anything, I usually just kind of trace out that circle. So you trace it out all the way around, but we are looking at the x values since that's what we equated these two limits to. So the x's are going to be from minus 3 to 3. And then we come back here to our function, and we see that the y values are from 0 to 3. So the y values will be from 0 to 3. So now we have both the limits of integration with respect to x and with respect to y. So we know that the region of integration is this region here, which is a semicircle. So we don't need the negative y values. Once we do that, we have to realize that this here, that curve, is part of the x squared plus y squared equals to 9. We can find the equation of this curve making y the subject of the equation, so that we can be able to get the y value of any point here. And to do that, we take the x squared plus y squared equals to 9, which is the equation of this circle, and we can make y the subject of the equation, this circle equation, and we're going to get y equals this, we'll get y equals plus or minus the square root of 9 minus x squared, but we are only interested in positive y values, the positive y values. So the equation of this curve at the top is going to be y equals to the square root of 9 minus x squared. All right, so now we do have both the left and the right limits of integration, and we have the bottom and the top limits of integration. The left right are from here, minus 3 to 3, and the bottom top are from this line here, which is y equals 0, and this curve here, which is y equals the square root of 9 minus x squared. Therefore, to express this with the order of integration changed, it's going to be the double integral. Let's start with the y values, because we are doing dy dx, since we are interchanging them from dx dy. So we know that the bottom limit is 0, and then the top limit, or rather the top function, is the square root of 9 minus x squared. And then for the x values, we know they go all the way from -3 to 3. And therefore this is this function here with the order of integration change from dx dy to dy dx.